the first taxonomy. No one remembers anything, is it? Okay, so the three algorithms were, one was k-means clustering technique. Then we have what is called k-medoids technique. And the third one, what we're supposed to discuss is CLARA. So these are the four different techniques to be discussed under partitional clustering. Still, the strength is only 27. I think the main issue is I take attendance towards the end. That's the reason. So does anyone remember what was k-means clustering? Ramcharan, do you remember what was k-means clustering? Yes or no? At least tell me a no. No way. Okay. So nobody wants to respond from this class. Right. So let's try. I'm not going to discuss the algorithm once again. I'll just show you a small analogy which I came across in one of the tutorial sites, which will help you to recollect what this k-means clustering is all about. Okay. So fine. So this is just to make you recollect what is k-means clustering. Okay, so suppose you went to a vegetable shop to buy some vegetables. Okay, so there you will find all sorts of vegetables, as how you can see here in this first figure out here. Okay, but then like, I mean, when you go to a vegetable shop, you will see that everything is being arranged in a group of its own type. For example, all the carrots will be bundled together, or all the fruits will be bundled together, all the beans would be bundled together. So everything, all the potatoes will be kept together. Okay, so you will find that they are forming a group or a cluster. Okay, so a cluster of vegetables. Okay, so where vegetables are kept within their kind of group. Okay, forming clusters. Okay, so that's basically the concept of your clustering, k-means clustering. Okay, so this is the figure before applying the k-means clustering technique. This is after applying the k-means clustering. Okay, so this k-means clustering algorithm, it will try to group similar items in the form of clusters. Okay, so the number of groups is represented by k. Okay, so it will try to find the similarity between the items and groups, items, and then it will group them into clusters. Okay, so do you remember the technique involved in k-means clustering? What were the steps involved in it? Okay, so either you start selecting random values for k, or the initial values would be given to you. The k is the number of clusters. Then you initialize the centroids. Then you select the group and find the average. Okay, so that was the brief technique. Then, of course, we had discussed the detailed algorithm where we were arbitrarily supposed to partition the objects into k group, updating the cluster centroids, the reassigning the objects and updating it, and the process or the loop gets repeated till there is no change. Okay, so then that's what we had discussed with the help of an example. Do you remember what was the distance measure that we had used in k-means clustering? At least put in the chat window. What was the distance measure which we had used?
Euclidean.
Yes, Euclidean distance measure. Okay, Euclidean distance measure, and our objective was to minimize the SSE, that is sum of squared error. Okay, so that was what our k-means clustering was all about. Okay, so but then if you look into the disadvantage, this k-means clustering do have some disadvantages. Okay, so it is basically sensitive to outliers. Okay, so choosing the k value manually, it's actually a difficult task. Okay, and again, as the number of dimensions increase, the scalability will be decreasing as far as a k-means clustering algorithm is concerned. Okay, so since an object with an extremely large value may substantially distort the distribution of data, so that's one of the disadvantage of this k-means clustering, where each cluster is represented by the mean value of the object in the particular cluster. Okay, so that was what our k-means algorithm was all about. So today we will look into the next algorithm called k-medoids algorithm. K-medoids. Okay, so I said Okay, so I said one of the problem with k-means is the centroid. Okay, so they are not the actual point. Okay, but it's actually the mean of the points present in the cluster. Okay, when you say centroid in a k-means clustering. Okay, so it is not the actual point, but it's the mean of the point. It's the average of the point present in that particular cluster. Okay, so when you say mean, we had already discussed about the measures of central tendency, where we discussed about mean, median, and mode. There we discussed about the advantages and disadvantages of mean. Okay, so one of the disadvantage of mean is the mean will get affected by the extreme points, especially if you have extreme values in your data set. Okay, so in the k-means algorithm, the centroid will get shifted to a wrong position. Okay, and hence you can result in the incorrect clustering if the data is having outliers, because then the other points will move away from it. Okay, so that's one of the disadvantages of k-means clustering. Okay, so in this new algorithm, what we are going to learn in today's class, k-medoids, instead of taking the mean value or the average value, you actually take what is called medoids. Medoids as a reference point. I'll tell you what it is. You take medoids as a reference point. Okay, so it is actually the most centrally located object in the cluster. That's what we call it as a medoid. Okay, so a medoid can be defined as a point in the cluster whose dissimilarities with all the other points in the cluster is minimum. Okay, so that's how the definition has been put forth for medoid. What is basically a medoid? So okay, so point in the cluster whose dissimilarities with the other points in the cluster is minimum. Okay, so the dissimilarity of the medoid represented as Ci and the object Pi is calculated by using the equation absolute value of Pi minus Ci. Okay, and this is the equation for the cost for the k-medoids algorithm. Okay, so um, you can see here, so this particular term, this particular term, the distance measure, it's a distance measure called, it's called the Manhattan distance. Just like we have for the mean k-means clustering, we have what is called the Euclidean distance. In k-medoids algorithm, we use what is called Manhattan distance, which is also called city block distance. There's one more name given for it in the net. I don't remember. I think some taxi cab or some name. One more name is there. So, but then it's popularly known as the Manhattan distance. Okay, so the Manhattan distance between the 2 points x1, y1 and x2, y2 is given by absolute value of x1 minus x2 plus y1 minus y2. Okay, so the distance measure used is Manhattan distance. Okay, so both your k-means clustering as well as your k-medoids clustering, so they will both attempt to minimize your SSE, that is your sum of squared error. Okay, but then your k-medoids algorithm, it's more robust to noise when compared to your k-means clustering or k-means algorithm, because you're not taking the mean into consideration. Okay, it's a medoid. Medoid means the most central element of the cluster. Okay, so the distance from the other points will be minimum. Okay, and again it will not get influenced by the extreme values, just like your k-means algorithm. Okay, so that's the reason why your k-medoids algorithm is more robust to outliers and noise when compared to your k-means clustering algorithm. And this is the cost equation. Okay, so this is the algorithm. I'll just mention what it is, then we'll work it out. We'll work out an example of k-medoids algorithm, which will make it more clear to you. Okay, so the first step, what you do is initialization step. You select k random points out of the n data points as medoids. Then Second step is associate each data point to the closest medoid by using any common distance metric method. Okay, so that's the second step. Then, while the cost decreases, for each medoid M, for each data point, which is not data point O, which is not a medoid, swap them. That is, swap your medoid and the data point which is not a medoid. Associate each data point to the closest medoid and recompute the cost. Okay, this is swapping step coming here. That's the central theme as far as the medoid is concerned. Okay, so if the total cost, after computing the cost, if the total cost is more than the previous step, then undo the swap. Okay, so that's what the concept of K-medoid algorithm is all about. Okay, so whenever there is a swap, we calculate the total cost with the sum of the distance of all the points in the cluster to the new medoid. Okay, so all the swaps that give a lower cost and perform the best one, the one which arrives at the lower cost. Okay, I'll explain with the help of an example that will make it more clear. Okay, so you can call the termination condition for K-medoids, like when the cost is no longer, when the cost cannot be decreased further. Okay, then we can say the algorithm terminates. The algorithm terminates if the cost can no longer be decreased. Okay, so because of that factor, it will not require an average value to arrive at the global minimum or whatever. Okay, so because we only perform the steps that are decreasing the cost. Okay, so the algorithm will have no way to get out of the local minimum and get into the global minimum or whatever. Okay, so now we'll look into an example. I've given an example out here. Okay, so this is we have 10 objects given here. 10 objects, these 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 objects. So for each object, the coordinate values are given here. Okay, request all of you to make a note of it, the data set, so that you don't sleep in the class. Otherwise, in the mid-afternoon, 1:30, when you listen, I mean, when you're listening to this, you will not feel like paying attention. So that's the reason. Please note down the data set. 10 objects with its coordinate values. Okay. For the 0th object, the coordinate values are 8, 7. 8th object 7, 5. 9th object 4, 5, and similarly. These are the 10 coordinate objects. 10 objects and their coordinate values, x value and the y value. Okay. So in case you're going to plot a graph, it will be something like this. Plot a graph, you will get something like this. Okay, so have you made a note of the points, data points, or at least click the picture in your mobile? At least one yes in the chat window.
Yes, ma'am.
Okay, good. Right. So thank you to whoever is listening and noting. Okay, so the next step. So what the first step says is you are randomly selecting two medoids. Okay, randomly selecting two medoids. So I'm selecting 4 and 5, 4, 5 and 8, 5 as the two medoids. So I can this one and this one. The 4th object and the 9th object are being randomly selected as the medoids. Okay. So C1 is 4, 5 and C2 is 8, 5. C1, C2. Okay. Right. So the next step. Okay, the next step is actually the computation of cost. Okay, so these are the medoids. This is C1, 4, 5. C2 is 8, 5. Okay, so the dissimilarity of each medoid point with the medoids is calculated and tabulated. Can somebody tell me how this value is 6 and how this value is 2? I'll give you 2 minutes time. You know the Manhattan distances, the formula for Manhattan distance. It's given as this. This is the distance measure. So with that, can you tell me how do you get these values? For this particular object, for the 0th object, which has got a coordinate 8 and 7, and with respect to the first medoid, that is 4,5, how do I land up with this value? Yeah, somebody was giving a try. How do you get it?
8 minus 4 plus 7 minus 5.
Yes, very good. The absolute value of it out here. Anyway, the absolute value doesn't make any difference. Okay, so it is 8 minus 4 plus 7 minus 5. Okay, so you get 4 plus 2 is equal to 6. So same way here. Mithun, how do you get 2 here? Mithun, how do you get 2 here? Mithun is sleeping in class? Santosh Kumar. How do you get a 2 here? Okay, let me ask my friend Rakesh. Rakesh, are you there in class? No way. Rakesh is not there in class. So today, Vitun, Santosh, Rakesh, all no attendance.
Ma'am.
There, who's it?
Vitun, ma'am.
Vitun. Any idea how do you get this 2? You seem to be busy with a lot of other activities.
No, ma'am.
You are deafening my ears. Okay, yeah. Can you just give a try regarding how do you get this value 2 here?
Can you point?
This one. How do you get this value?
7 minus 5.
Wow, 7 minus 5 is 2. To be more precise, yeah. What you said is correct. So it is 8, 7 and 8, 5, right? So 8 minus 8 plus 7 minus 5. So as you said, 7 minus 5, 8 minus 8. I hope you knew this particular step or you randomly told. Okay, so that is how you get the value as 2. Similarly, compute for all the things. Okay, so for each object, compute the dissimilarity of each non-medoid point with the medoid. Okay, so these are all the non-medoids. Okay, so you calculate the dissimilarity of each non-medoid point with the medoid point. Okay, I hope you have made a note of it in your notebooks, those who are listening in the class. Okay, so then I'm coming to the next step. Okay, so now, so each point, okay, so each point is assigned to the cluster of that medoid whose dissimilarity is less. Okay, so in the sense here, when you see these 2 points, so here the dissimilarity is less in the sense the value is 2 out here. Okay, so what happens? So the object 0 goes to cluster C2. Okay, object 0 goes to cluster C2. Object C1 and C2. So object 0 goes to cluster C2. Then what about object 1? Which cluster does it go to? Object 1. Somebody can tell. What does it say? What does the thing says? It tells you each point is assigned to the cluster of that medoid whose dissimilarity is less. Okay, dissimilarity is less. Okay, so comparing these two values here, this is the one with the less dissimilarity. Okay, so it belongs to C2. So object 0 is being assigned to cluster C2. Then what about the object 1? Object 1 will be assigned to cluster, comparing to 3 and 7, it will be assigned to cluster 1. Cluster 1. Okay, so then what about the next one? Object 2. Object 2 will also be assigned to comparing these two. Object 2 will be assigned to cluster 1, C1. Okay, so can you fill the remaining and tell me what are the objects which belong to cluster C1 and what are the objects which belong to cluster C2? Can somebody tell me? Sriram, are you there?
Yes, ma'am. Yes, ma'am.
I'm calling out your name after a long time, no, Sriram?
Yes, ma'am.
So can you tell me what are the objects which belong to C1? And what?
C1.
I told 1 belongs to C1, 2 belongs to C2. I mean, 2 also belongs to C1. Or somebody who's willing to give me an answer. What are the other objects which belong to cluster C1? What about object 3? Object 3.
3 is C2, ma'am.
3 is C2. And object 4 is the medoid. No need. Okay. Then object 5. C1.
C1, ma'am.
Okay. So then object 6 is C2. Object 7 is C2. Object 8 is also C2. Right? So that's what. Okay. So you can see here 1, 2 and 5 goes to C1. 1, 2 and 5 goes to C1. And 0, 3, 6, 7, 8. 0, 3, 6, 7, 8 goes to cluster C2. Okay. So then what are the costs associated with them? Okay. What are the costs associated with them? The cost associated. Just a second. Signatures. Mechanical HOD. Okay, sir. Okay, sir. Thank you. Sorry. Right. Okay, so the cost associated with them. The cost associated with them. So will be you add the cost. You add the cost associated with each of them. With 1, 2, and 5. Similarly, 3, 0, 3, 6, and 7. So you add the cost, you get the value as 20. Okay, that's the second step. Okay, so now coming to the third step. Okay, third step, what you do is you initially computed the cost. You found out the dissimilarity of the non-medoid points with respect to the medoids. Then now you randomly select one non-medoid point and recalculate the cost. Okay, so previously our medoid was 8, 5 and 4, 5. 8, 5 and 4, 5. Okay, so 4, 5 you are retaining as such. And in the second round, you are having a new medoid, 8, 4. Okay, 8, 4. This was the first one, wherein we calculated the cost as 20. Now, you randomly select 2 points, 8, 4. Select a point, 8, 4. Then the dissimilarity of each non-medoid with the medoid point, that is 4, 5 and 8, 4. So that is calculated and tabulated, just like the previous one. Okay, so dissimilarity, these are the 2 medoid points right now. So you calculate the dissimilarity of the non-medoid points with respect to the medoid points and then assign it to appropriate clusters. Okay, assign it to appropriate clusters. Can you, I'll just give you 2 minutes. Can you do that by the time I take attendance? With respect to this, you tell me what are the clusters to which they are going to get assigned to. Okay, so whether the clusters are changing. Assign the various objects to the clusters based on this least dissimilarity. So meanwhile, let me take the attendance. Anirudh?
Present, ma'am.
Dharini?
Present, ma'am.
Ramharini?
Present, ma'am.
Kalyan Sundar?
Present, ma'am.
Aravind? Is anyone giving through the chat window? No, right? Fine. Okay. Sharan Varghese,
Present, ma'am.
Shakti Priya,
Present, ma'am.
Nishok, 23, Nishok. No. Shreya,
Present, ma'am.
Shreya started working out.
Yes, ma'am.
Are you following?
Yes, ma'am.
Suveda,
Present, ma'am.
Vishal,
Present, ma'am.
Srimati,
Present, ma'am.
Nityashri,
Yes, ma'am.
Pranav Ram.
Present, ma'am.
Pranav finished.
Yes, ma'am.
Srimati, yes.
Present, ma'am.
Raja Singh,
Present, ma'am.
Pooja.
Yes, ma'am.
Is somebody trying to give something through the chat window? Nishok present. What Nishok was sleeping?
Ma'am, no, ma'am. A new laptop came, ma'am, so I gone, ma'am.
Okay, fine. 54 is Lavanya. Noted, noted.
Present, ma'am.
Nityashri,
Present, ma'am.
Sriram,
Present, ma'am.
Likita, 27. Likita is absent. Satyamohan,
Chat
Sharon?
box, ma'am.
Okay, okay.
Chat box, ma'am.
Fine, fine, fine. Satyamohan, I have noted. Likita is absent. Okay, 63. Sharon is also noted. 67. Aviral Patel.
Present, ma'am.
Hemavartini.
Present, ma'am.
71. Ajay.
Chat box, ma'am.
Okay, noted, noted. Akshata Saha.
Ma'am.
Okay. 80. Karthik Balaji.
Present, ma'am.
Santosh Kumar.
Yes, ma'am.
Anand Arun. Anand Arun, 115 is absent. Rahul. Rahul P, 116. Suhasini Srikanth. Oh, Rahul is present. Okay, noted in the chat window. Anand Arun, there is no response, right? Okay, 117. Suhasini.
Present, ma'am.
118.
Present, ma'am.
Vithun.
Present, ma'am.
Adityan.
Present, ma'am.
Selva Niklesh. 121. Class rep is absent today, yeah? Ram Charan, okay, noted in the chat window. 123. Achinta Murari.
Present, ma'am.
Finished, Achinta?
Ma'am, doing, ma'am.
Doing. Okay, Santosh Kumar. 145. Okay, noted. Pavitra Shri.
Present, ma'am.
149.
Present, ma'am.
Rakesh. Nityashri Narasimhan. 1 from C section. No, Nishok Kathiraven. 25. 171. Rakesh present, ma'am. Rakesh is one outlier in this class. Nishok Kathiraven. 12. Abel Prashant.
Yes, ma'am.
Abel 25 is present. 28, Preetika. Okay, noted. 40, Kevin Kurian Joseph.
Present, ma'am.
Hiten. Adya.
Present, ma'am.
Ma'am, 45 present, ma'am. Hiten. Sorry, ma'am.
45, okay, noted. 51 is also present. Jay Vora.
Yes, ma'am.
Okay. 57, Kishore.
Present, ma'am.
Sridevi.
Present, ma'am.
Yash Rai. Okay, noted. Jayesh Kumar. No response.
Present, ma'am. Jayesh present, ma'am.
Okay. Anybody who has missed the attendance? 12. Nishoka Thiraven. Okay, then. Okay, can't talk. 12 present. Okay. Okay, given the attendance to can't talk. Then who's it? That's it, right? Anybody else? From any of the. Don't simply put in the chat window and tell that you are giving, you can expect an attendance. Anybody from A section who has missed an attendance, you can tell me now.
27 present, ma'am.
27, is it? Post 27, Likita. Where were you when I called out the attendance?
Ma'am, I went to answer the doorbell, ma'am.
Okay, so I hope I've given attendance to everybody. Okay, now let's get back to our problem. Okay, so what are the clusters to which these points are getting, objects are getting assigned to? Can somebody quickly tell me? What is cluster 1 having? What is cluster 2 having with respect to this assignment? Medoids assignment?
Objects.
Tell me. Yeah, please tell. Let's see. Okay, Pranav has put it. Yeah, 1, 2, 5. One second. Let me open the chat window. Okay, 1, 2, 5 goes to cluster C1. Very good. Then, yeah, 0, 3, 4, 6, 8. Yeah, everything goes to, yeah, the remaining goes to cluster C2. Correct. Yeah, okay. So the new cost, cost with respect to this is, the cost will be 22 out here. Okay, so 22. So what does it tell? What does our algorithm tell you? What does our algorithm tell? In case we have a higher cost. So if the total cost is more than the previous step, undo the swap. Okay, so what was the previous cost for us? The previous cost was 22. Okay, previous cost was 22, and now the cost is, okay, the new cost is 22. The current cost is 22 and the previous cost is 20 for us. Okay, so in that case, what you do is you compute the swap cost. Okay, the new cost minus the previous cost. Okay, new cost is 22 minus the previous cost is 20. Okay, you will end up with 2. So that's greater than 0. Okay, so the swap cost is not less than 0. So what we do is we undo the swap. Okay, so when you undo the swap, what was our initial medoids? Our initial medoids was 8, 5 and 4, 5. Okay, so we are undoing the swap by considering 8, 4 and 4, 5. So in this case, we undo the swap. So 8, 5 and 4, 5 are the final medoids. Okay, so with that, so 8, 5 and 4, 5, when it was the medoids, so these points were assigned to cluster C1 and these points were assigned to cluster C2. So that was the final assignment. So that will be the final assignment. Okay, so that's what your K medoids clustering algorithm is all about. Okay, so you initialize, select K random points out of n data points as medoids, associate each point to the closest medoid by using any common distance metric method. Then you, as the cost is decreasing, for each medoid and for each non-medoid, swap M and O, associate each point to the closest medoid, recompute the cost. Okay, if the total cost is more than the previous step, undo the swap. Okay, so the initially our cost was 20. In the second round, the cost was 22. Okay, so it's more than the previous step. So we undid the swap and then made the final cluster assignments. Okay, so that was what is K medoids algorithm, which is called PALM technique, that is partitioning around the medoids. Okay, so partitioning around the medoids, and that's why we call it as a PALM technique. K medoids is partitioning around the medoid. So now moving on to the next technique. So next technique we have, okay, so now coming to the advantages and disadvantages. So this algorithm is considered to be more robust than your K-means clustering technique. It's simple, easy to understand, easy to implement, fast to converge, okay, less sensitive to outliers because we're not considering the average value. But then the disadvantage is it's more computationally expensive and it's not suitable for large data set. And again, storage is a problem and it's computationally complex. Okay, and it's not suitable for clustering non-spherical groups of objects, that is arbitrary shaped objects. Okay, so that's because it believes in minimizing the distance between the non-medoid objects and the medoids. That's a cluster center. Okay, so that's these are the disadvantage. Okay, so it may obtain different results for different runs on the same data set because the first k medoids are chosen randomly. Okay, so the first k medoids are chosen randomly. In the next round, one is kept as such and another one is being chosen randomly. So because of this, you may obtain different results for different runs on the same data set. Computationally expensive, more storage required, and it's not good for large data sets. Okay, so for clustering large data sets, we have what is called as Clara technique. Clustering large applications, CLARA. Okay, so this Clara is known as clustering large applications algorithm. Okay, so actually this is an improvised version of your k-medoids technique. Okay, this is suitable for dealing with data containing a large number of objects. Okay, when you have thousands of observation, or when you have 10,000 of observation. Okay, so in order to reduce the computing time, rather than going for k-medoids technique, you go for what is called Clara. Okay, so that's the concept of Clara. Okay, so the whole idea is, okay, instead of taking the whole set of data into consideration, okay, so a small portion of the actual data is chosen as the representative of the data. Okay, so then after that, from the samples, medoids are then chosen from this sample using PALM. PALM is nothing but your partitioning across or around the medoids, partitioning around the medoids. So that's what is PALM. Okay, so then the sample is selected randomly. Okay, so CLARA, Clara technique, draws multiple samples of the data set, applies PALM on each sample, and returns its best clustering as the output. Okay, then again, the effectiveness of Clara depends on the sample size. Okay, so that's what is Clara technique all about. Okay, so instead of taking the whole data set into consideration, a small portion of the actual data set is a sample is being drawn. Okay, so various samples of certain size is being drawn, and from there, from the various samples, medoids are chosen. Okay, using partitioning across medoids. Okay, so and and it will return, applies PALM on each sample. You apply the PALM technique on each of the samples which is being drawn, and that will return the best clustering as the output. Okay, so it's an improvised version of k-medoids since it applies clustering by selecting samples from data. So it is, it deals with larger data set. Then again, as the sample size increases, its effectiveness increases, or vice versa. Okay, so you can see here, it is not worked out, only the concept is being mentioned out here. Okay, so this is the Clara algorithm's functioning. So you have, these are the records or tuples, whatever names you can call it. Okay, so you have, say, around 1,000 records or tuples are there. Okay, so each with its coordinate values. So you're choosing the samples, sample S1, S2, S3, S4, Sn, so S5 up to Sn. You're choosing samples. So each sample can be of some size. Say each sample can have 20 records or 40 records or whatever, depending upon how you divide the population. Okay, so that's what samples are being drawn from the records. And what is the next step after the samples are drawn? Just to check whether you're
Apply k-medoids.
Yes, very good. Apply the k-medoids technique. So that's what it says. See, medoids are then chosen. Yeah, Clara draws multiple samples of the data set, applies PALM on each sample, and returns its best clustering as the output. Okay, so that's what. See, from this, these are the various samples which are being drawn. Okay, various samples which are being drawn. Okay, then it's applying PALM on each of these samples. See, sample 1, sample 2, sample 3. It's applying partitioning across medoids, and as a result, using the technique, you get the clusters. Got it. So this is how Clara algorithm functions. Clustering large applications. And large applications technique. Okay, so that's what. So you draw randomly multiple samples from the original database with fixed size, apply PALM algorithm on each sample and choose the corresponding K representative objects or medoids and assign each observation of the entire sample to the closest medoid. Then you calculate the mean or sum of the dissimilarities of the observation to their closest medoid for good quality clusters. Then the sample for which the mean is minimum, you recall the sample for which the mean is minimum and continue repeating the above steps to the final clustering. Okay, so now that completes our partitioning clustering techniques. What are the three partitioning clustering techniques that we have discussed? Next, we need to start with the next technique. What are the three partitioning techniques that we had discussed? These are the three partitioning clustering techniques. One is the K-means clustering technique, then K-medoids clustering technique, which is nothing but a PALM, a partitioning around medoids technique, then an improvised version of PALM, K-medoid. Which is nothing but Clara. Clara is for clustering large applications. Okay, so these are the three algorithms which we are learning. So next is actually hierarchical clustering. Hierarchical clustering. So that we will take up in tomorrow's class. So today we'll just have a recap of the various partition clustering technique. If you have any doubts or anything, you can ask me. See, this was the clustering, K-means clustering, which we discussed before your CPS. Okay, wherein we determine the number of clusters before the algorithm started called K. Okay, choose randomly. They become the initial cluster centers. Okay, you compute the average of the initial clusters, assign the remaining sample to the closest cluster based on the Euclidean distance. I hope you remember what was Euclidean distance. Square root of x1 minus x2 to the whole square plus y1 minus y2 to the whole square. Okay, so then you compute the new centroid using the newly considering the newly added sample. Okay, you repeat the steps 3 and 4 till the thing becomes stable. Algorithm becomes stable. That means there is no changes in assignment of the instances and the clusters. Okay, so that's what. So then the metric that is being used both in your K-means and K-medoids is nothing but sum of squared error, and the objective is basically to minimize your sum of squared error. Okay, so you're basically trying to partition n samples to K clusters in order to minimize the sum SSE. Okay, the advantages and disadvantages, it's susceptible to outliers. That's the main disadvantage of your K-means clustering. Okay, so how to choose the value of K? Actually, there is one more technique called Silhouette method for choosing the value of K, but then this is the most popular method, and this is not anyway advanced data mining or advanced machine learning. So I just gave you the most discuss the most popular method of choosing the value of K, nothing but your elbow method. Elbow method. Okay, so the elbow method for choosing the K. Okay, then I gave you this illustration, a simple illustration of K-means clustering. The initial seed values are given here. Okay, the initial values are given 4, 6 and 12, 4. Okay, initial clusters, computed the mean. Okay, it's only one sample, so it's the same. Okay, then you computed the distance between the cluster centers, that is the centroids and the data points. Okay, using the Euclidean distance measure, then assigned appropriately to the clusters designated as V1 and V2 based on the mean distance. Okay, so see these. then these two. That's V1 and V2. Okay. Then after the first iteration, this was the cluster. Then you recalculated the cluster centers. So that is average of data points. Okay. You had 3 points. That's by 1 by 3 into all these, added up with the value 4, 6. Similarly, you recalculate the cluster center V2. Okay. 2 points. That's why 1 by 2. Okay. Get V1 and V2 are now 4, 6 and 11, 4 respectively. So you repeat from the previous step till you get the same cluster centers as in the previous iteration. Okay, so this is the next assignment. So there's no change. It's exactly same as the previous iteration. Okay, so these are the 2 points. Okay, so the points assigned to each cluster. This is cluster 1 and this is cluster 2. So you can graphically represent them. What are the contents of your cluster C1 and cluster C2? Cluster C1 will have, you need to plot it, okay, 2, 4, 4, 6 and 6, 8. And this is having the values 10, 4 and 12, 4. In a graph sheet, you can plot it and represent the clusters. Okay. Then we started today's class with an analogy of vegetables to understand, to recollect your k-means clustering. Okay, this was something that was given in your standard textbook PPT. Okay, so the k-means clustering depicted. So the issue, we discussed what are the problems associated with k-means. Okay, to overcome that, we have the concept of what is called your medoids. Okay, so medoids, the point in the cluster. Okay, whose dissimilarity with other points in the cluster is minimum. Okay, so the dissimilarity is computed as absolute value of the object pi minus the medoid and the cost factor, sum of everything. Okay, so then it's called the distance measure, officially called Manhattan distance. So this is the k-medoids algorithm all about. Okay, gave you this illustration. Okay, so calculated the cost for initially to be 20. In second round, the cost came to 22. Okay, so since the new cost is more than the previous cost, okay, so you are undoing the swap and these are the final medoids. Okay, so then it's not suitable for large data sets. For large data sets, we have this technique called Clara. Okay, draws samples. Okay, on each sample, you apply the partitioning around medoids and then assign to the appropriate clusters. Okay, so that's what. Right, you have any doubts, you can ask me. Otherwise, we are winding up for the day. Thank you.